Hello and welcome everyone. In this video we will see if we switch two elements with each other, what two would have the biggest impact. Welcome to the question answer channel, the channel where you will find the answer to everything. Thanks to Sasha Boone, Anonymous, Vegard Storns Farstad and Dylan Owens for sharing their views on this question. Let's go for Sasha Boone's first answer.
Hydrogen with oganesson, the most common element in the universe with the heaviest, so far. Every star instantly goes kabam as the oganesson decays in under a second. In 8 minutes, Earth is permeated with gamma radiation. This is an image just milliseconds after a nuclear detonation. The power of a nuclear blast is released as gamma rays, which must be absorbed by nearby air to be converted into the expanding fireball. But what about those weird spikes? What's different there? Those are cables holding the bomb stable. When it detonates, gamma rays hitting the steel cables are absorbed much more than they are by the less dense air. Spikes form where the steel is vaporized by the gamma rays passing through, but the effect on the air isn't enough to cause a fireball. The same happens to the planets. In 3 minutes, Mercury vaporises itself, before merging with the expanding sun fireball. Venus comes at just under 6 minutes, Earth at 8.5. Mars is next. Every asteroid then ignites in a fireworks show/firestorm, before becoming an insignificant lump on the expanding relativistic fireball and radioactive hell that was once the sun. The gas giants went up in the instant of conversion, being largely made of hydrogen, and their moons have been destroyed too. Their shockwaves merge with the sun's into one. The comets, interstellar gas, every other star and every other galaxy all go up in a similarly spectacular fireworks show. This is the biggest event since reionisation. Everything is reset into the early universal conditions. Dave Consiglio would most definitely approve. P.S. It's not painful because you, being largely composed of water, would be vaporized in under a millisecond. Earth as a whole would be an expanding, but not yet a very big fireball by the time the sun's gamma ray shell hits. Everyone, most definitely, dies. I was considering hydrogen to nitrogen, the 2 extra bonds forming make the gas giants blow up, but I realized that the sun wouldn't be as affected. I also considered hydrogen or oxygen to fluorine, but they are just chemical energy still. The sun is the best way to kill everyone, and it is only affected by nuclear energy. Hence this. Note. I did the calculation, and, given that 1 electron-volt is equal to approximately 10,000 kelvins in the decay chain of oganesson, or at least, the first 3 decays in about 15 milliseconds, releases 30 MeV, the sun will be at 300 billion kelvins in well under a second. Nothing in nature is that hot.
What do you think? We will continue with Anonymous's answer.
It depends on when you measure the impact. In the short, moderate and very long term, Sasha Boone's proposal of hydrogen less than to oganesson looks to be greatest, though hydrogen less than to helium is possibly even more disruptive at intermediate timescales. At the risk of boring the pants off anyone silly enough to spend time reading this, I'll take this as an implicit invitation to consider a range of options. Swapping any of hydrogen, nitrogen, oxygen or carbon with any other element would instantaneously destroy all amino acids and hence all life. Everything dies. I assume that this satisfies the Consiglio criterion. Any swap involving many other elements, including phosphorus, potassium, sodium, magnesium, calcium, sulfur, chlorine, iodine, would rapidly, but probably not instantaneously, destroy all higher life forms. It won't matter to us what happens after this, but out of purely abstract interest, we might look at planetary, stellar, and cosmological changes. I will give some examples. The least disruptive effects, in human timescales, would come from swapping over some of the transuranium elements. Depending on choice, some products would stop working correctly and might become dangerous, smoke alarms, medical diagnostic equipment, but life would mostly go on as before. However, if the topology of the universe truly is flat, even such a small change would be sufficient to convert continuing universal expansion into a big crunch, or to cause an acceleration of the expansion, depending on the choice of swap. Swapping oxygen with any of lithium, beryllium or nitrogen would initially cause significant chemical disruption, but in most cases I do not believe that this would be sufficient to vaporize the planets. As examples, swapping oxygen with lithium would produce lithium hydride with free hydrogen, lots of bubbly activity, and the hydrogen would eventually be released to the solar wind. Swapping oxygen with carbon would turn our oceans to carbon dioxide. The surface would almost instantaneously turn to a mix of dry ice and CO2 vapor. Longer term, the Earth would acquire a thick mantle of CO2. In all cases, the redistribution of mass would lead to terrific volcanic activity. The effect on planetary orbits will depend on the initial momentum of the replacement atoms. If momentum is conserved, the inner solar planets would transfer to significantly elliptical orbits with minor axes similar to current values. If mean velocity was conserved, the planets would continue in orbit similar to present. Moons of inner planets would be significantly affected, as the gravity of their hosts reduced. However, the major effect would be a long-term cosmological change. The universe is currently thought to be telogically flat on the larger scale, and there is little doubt that it would become open, so the acceleration of universal expansion would be significant. Becoming more extreme, swapping hydrogen with helium would blow all organic matter and water apart, compact planetary and lunar orbits, and cause all stars to start collapsing. The, now, predominantly helium inner regions of the stars, now oversized cores, in practical terms, would largely convert to carbon with energy release vastly in excess of that produced in any normal collapse. The medium-term result would in most cases be blue giants, like red giants but hotter and therefore larger in spite of the greater gravity. Surface emissions would almost certainly exceed those of a red dwarf. Once the star cools, I imagine the mass boundary between neutron star and black hole formation would be shifted to somewhat smaller dimensions than presently, but I think the change would be relatively small. The ultimate effect of increasing the visible matter by a factor of over 3 would be to close the topology of the universe, resulting in a collapse in a time comparable with the present age. The most rapidly extreme example is to swap hydrogen with oganesson as suggested by Sasha Boone. As with any other hydrogen swap, this would instantaneously end all life. Although it would probably not release as much total nuclear energy as swapping hydrogen with helium, most of the energy would be released in a time that is short compared with transit times through the sun, so there would be lots of, unobserved, spectacular stellar explosions all over the universe. Longer term, the visible mass in the universe would increase by a factor of about 220 and the total mass by a factor of 33. So the big crunch would come in a time that is short compared with the present age of the universe. GS.
The next answer is from Vegard Storns Farstad.
I would argue hydrogen and helium, since most of the matter in the universe consists of the two elements. Switching them would switch the ratios and dramatically reduce the lifespans of main sequence stars.
We can continue with Dylan Owens' answer.
The chances are incredibly small, but yes, it's possible. These are from the Battle of Gallipoli. There were so many bullets flying around. Two of them not only collided, but fused together. These two are from the American Civil War. And these are from the Crimean War. The chances are astronomically small, but with thousands of bullets flying at the same time, it gets more and more probable. Pretty cool.
This is the end of the video. I hope you have more answers. If this answer helps you, please help us too by leaving a like and subscribing to this channel. It allows us to move forward on YouTube. This is now the end of this video. Remember to leave a comment to tell us if these answers resonate with you. Bye and see you soon.